Hey everyone, and welcome to the R tutorial. So today we'll be doing a quick introduction to RStudio, which is the environment that you'll be working with code in. And we're going to practice loading in a data set, doing some manipulation on the data set, kind of just understanding the environment. We're going to give you all the tools you need to kind of do the first homework and start thinking about, the relationships between variables and also how to describe variables. So what I have here is RStudio. I've already opened it up. So this is about what you should see when you open it up for the first time on your computer. So what you can see on the left-hand side is this kind of area with some information about the RStudio version that you have and this label console. The console is where you can enter in commands and basically you can kind of use the console as almost a calculator. This is kind of if you want to just enter something and see something returned to you. So for instance, where the flashing cursor is, if I just enter 2 plus 2, we'll see that R returns 4. And we can use all of our kind of standard operations here, including the little star for multiplication. We can use a backslash for division. There's other, and let's say the exponent for exponentiation. There's lots of other things that we can do. So for instance, taking a square root, you can do with the command sqrt. And in general, anything that you can do on your calculator, you can kind of do right here in the console. So that's all kind of fine. So that's good. Over here in the upper right, what we can see is this thing that says environment is empty. This is part of the global environment. Once we start loading in data and once we start creating new variables, the data set name and the variable names will appear here in the upper right. In the bottom right, we can kind of see that there's this screen that has 5 different tabs. So there's file, where you can kind of navigate through the directories of your computer. Plots, if you've created anything graphical, we'll come back to that. We have packages, which are kind of extensions to R, one of which we'll need right away. So coming back to this very quickly. Help. So help provides information about commands, and then viewer. Okay. So the first thing that we're going to want to do is attach a package. Okay. So the package is called tidyverse. It'll provide a big set of commands and graphing tools. And for the rest of the term, it'll pretty much be the only package that we need. So if you don't already have it installed, to install a new package, what you do is you click that install button, you search for the name, in this case, tidyverse. It should bring something up. You can click it, and then you click install, making sure that dependencies is also checkmarked. So once you install, you'll see a bunch of stuff kind of showing up here. Hopefully the result of which is package tidyverse successfully unpacked, MD5 sum checked. Okay. So once you've installed it, then you can kind of look through this list of packages that we access in this bottom right pane. Scrolling down until we reach the T's. And here's tidyverse. Okay. So to make this package available for us to use, we'll just click this check mark. Okay. And then the result of that will be this kind of little output here. And we'll kind of return to our blinking cursor. Okay. Perfect. All right. So the first thing that we're going to want to do is import a data set. Okay. And the data set that is going to be imported today is the BRFSS, which is the behavioral risk factors kind of surveillance data from the United States. It's kind of a yearly survey that they do on a lot of health and demographic information. So to import data, what you're going to do, you'll go to File, scroll down to Import Data Set. And then this is important. You're going to want to use this second option, Reader. Don't use base. And in order to use Reader, you will need to have had tidyverse attached. So if you try to use it and it doesn't work, it means that you didn't attach tidyverse. So be sure to attach that. So we'll look for some data. So wherever you stored this file, BRFSS 2018, that you downloaded from Quarkus, you just navigate to that, click open. It'll give you a preview of what you're about to be loading into the RStudio, which looks basically like an Excel spreadsheet. And then we import it. Okay. So what's just happened? This new thing in the upper left has appeared, which is a preview of our data. So we can see all of these different numbers: ALK-Day 5, flu shot 6, NUVAC 4, SEX 1, EDUCA. And then in the upper right, we can see that our data has appeared in our global environment. Okay. So this is the name of the data set. The name will be automatically assigned by R. It'll just be the file name as it is saved on your computer hard drive. Okay. So here we are. And from here, we can look at the data. Okay. We can just visually inspect it. You should always do this. Whenever you're loading a new data set, you should just kind of take a look at it and see what kind of values each of these different columns have, each of these different variables. And we can see, so for ALK-Day 5, we can see, okay, some zeros, some ones. So maybe this is a 0, 1 variable, right? So if we scroll through, but no, then, okay, we see there's a 7 here. Here's a 2, okay. So we can see that it takes a bunch of different values. Flu shot 6, we can see, okay, this seems to be zeros and ones. Same for NUVAC 4. Same for SEX 1. EDUCA seems to be taking, 6, 5, 4, 3, maybe 2 and 1 as well. Yeah, here's a 2 down here. Okay. Okay, so we're just kind of getting a sense. When we look at this, it basically tells us, yeah, okay, these variables are discrete variables. They take on kind of a finite number of values. Some of these look like they're Bernoulli or binary variables, taking on only zeros and ones. Okay. One other thing that we see is the NA. It's kind of grayed out. What is NA? NA is not kind of a real value. It's a flag for a missing value. So this is survey data. So the NA will appear if someone didn't answer that particular question. So, person 2, as they were answering the survey, they answered information about, this variable, NUVAC 4, SEX 1, EDUCA, but they didn't answer about ALK-Day 5. So it's flagged as an NA. So this NA is not useful to us, and it kind of makes the whole observation not very useful if what we're interested in is ALK-Day 5. So we'll figure out how to deal with that, with these missing values, okay? Now you might be wondering, okay, like well and good, but like what are these variables actually representing? So R can't tell you that. To know what a variable actually means, what it's representing, you'll need to go into the code book. So the code book is a PDF that's kind of associated with the data set. You'll have access to the code book through Quarkus, and it'll describe, what is this variable? So for ALK-Day 5, the variable is how many days during the past week did you have an alcoholic drink? Okay. So this person had 0 alcoholic drinks in the past week. Whenever the survey was asked, just kind of looking at the prior week. But, we have some people with 1, we had that person with 7. So they were having a drink every day of the week. And that will also give you the sense that, okay, this value can't be more than 7 because there's only 7 days in a week. So you can't be having a drink more than there are days in the week, right? You can have a drink every day of the week, but that's the maximum. Okay, so this takes values from 0 to 7. Flu shot 6, NUVAC 4, similar, they'll be in the code book, but 1 if you had your flu shot, 0 if you didn't, 1 if you had your kind of pneumonia shot or your pneumonia vaccine, 0 if you didn't. SEX 1, I believe this is 1 if you're female, 0 if you're male. You can double check that. And then EDUCA, we have kind of these different values representing different levels of education, okay? So like lower values are going to be, kind of just high school, then a bachelor degree, then, some postgraduate, and then maybe, you know, all the way up to a graduate degree. Okay. So good. So the code book will tell you kind of what these numbers mean, like in language, in words. Okay. Perfect. All right. So now let's start thinking about, you know, questions that we might want to answer with this data. Okay. So, you know, we might be thinking, all right, well, Alk Day 5, number of days in the past week that you've had an alcoholic beverage. You know, I kind of want to learn a little bit about that. Like I want to know, you know, what's the average number of days in the past week that people have had an alcoholic beverage. And I might also want to know, you know, by, you know, gender, is there kind of a difference between men and women in the average number of days in the past week that they had an alcoholic beverage? Okay. So one thing that you can do is you can just kind of play around in the console. Okay. So if you want to find the mean of a variable in a data set, here's what you need to do. You start with the name of the data set. So once I start typing BRFSS, actually R will kind of autocomplete. It'll find that, you know, okay, you're looking for this object, and then I can just, on a Windows computer anyway, hit tab and it'll complete. Okay. If I want to find the mean, I'll use kind of this operator here. And then I'll ask R to summarize. And what do I want to summarize? I want it to take the mean of Alk Day 5. Okay. So I kind of have entered in this thing here. This will not modify the data set. So this will just take kind of this column, and just like an Excel command, you know, mean of, you know, rows 2 through whatever, it'll just kind of find the average. Okay. So if I hit enter, I get this little output. Okay. So here we have what we're finding. This is the mean of Alk Day 5. This is what type of data this is. Double means it's sort of a number. Okay. There's also things like string, which is going to be a character. There's integer, which would be a number that's like a 1, 2, 3, 4, 5, but not a decimal. But here what we've ended up with is NA. Okay. So this is not very informative. So what happened? Well, if we try to take the mean with a piece of missing data, in Excel, it's automatically going to be ignored. In R, it's not going to ignore it automatically. It's going to assume that, you know, somehow this is important. But if you try to take the average of numbers with something that's missing, it's not going to know what to do. So it's going to return something that's missing. Okay. So it's not going to be useful. So what we're going to do is we're going to create a new data set, which eliminates all of these NAs, all of these missing observations. And then that's going to be the data set that we actually kind of do our work on. Okay. So to create a new data set, what we're going to do is we're going to type. Okay, what we could do is type in the console some commands. But what I would like you to do is click this file here, this button here, new file. It's going to open some options. I want you to click R script. Okay. So R script is going to open a new tab here, and this is going to say untitled 1. And what this is going to be a list of kind of commands that you can enter. And if you run all the commands, it'll kind of create output for you in the console. But what it allows you to do is kind of like keep track of all the steps that you're taking, all the work that you're doing, so that, you know, if you reload R and you kind of like reload this data set, you can kind of run through it all again, and it'll give you the exact same output. I'll show you what I mean precisely. But this is kind of the benefit of this language versus something like Excel, where, you know, if you give me the raw data and your code, then if I run your code on the data, I should get the exact same stuff that you did when you ran your code on the raw data. So it's very good for reproducibility and, you know, for kind of like modifying it and going forward if you are collaborating with people. Okay. So back to what we're trying to do. We tried to take the mean of Alk Day 5. Didn't work because we have a missing value. I said, let's figure out how to drop the missing values. So here's what we're going to do. We're going to create a new data set, and the new data set name, I'm going to call it just DAT. Okay. So DAT is going to be the name for our new data set. And to drop all of the NAs, we're going to use this command filter. Okay, so filter, you can see when you enter a command, or when you enter something that R kind of recognizes, in this case, filter is a function. Filter kind of operations are going to be brought up. So use filter to find rows and cases where conditions are true. So what we wanted to find is in BRFSS 2018, we're going to use this complete cases. Okay, so we only want rows, we only want observations from our original data set where it's complete. That is, there's no missing data. Okay. Unlike with the console, if kind of we hit enter here, nothing's going to happen. What we need to do is we need to select this and then click run. Okay. So we click run. It has appeared down here. So it's basically just like put the command into the console and run it. And up in the top right now, we can see we have a new object in our environment, DAT. And DAT is smaller, right? We can see it has 242,000 observations instead of 437,000. And if we click DAT, what we can immediately notice is that there's no more NAs. Okay. Every time there was a missing value, that entire row gets dropped. Okay. So for BRFS 2018, this row 2 would have been completely dropped, right? So DAT now, let's go back to our script. What we're going to do is use that same summarize command. So we want to summarize the data by taking the mean of ALK-Day5 and again, making sure that we're operating now on DAT and not BRFSS. Okay. So again, we're going to kind of select this guy, run it, and then here's what we see. All right. So what we can see is that this number is 5.62. Okay. So this looks like actually the average number of days that people are drinking in this data set is almost 6 days a week, right? So that's every day maybe but one, right? So that seems quite high, right? That seems quite high. You might be like, well, that's weird. Like when I look through DAT, these seem to be mostly zeros. You know, there's a 5 occasionally, but like, how are we getting so high? Like, how are we getting such a large number? Okay. So one way to explore the data, you know, we kind of have seen the mean, right? But what else can we do? So one other summary that we could do is we could say, okay, like, what are the different values that ALK-Day5 actually takes in this data set? Okay. And to do that, what we're going to use is another command where we're going to look at DAT and we're going to use this group by command. Okay. Group by is basically going to say within DAT, I want you to look by all the different values of ALK-Day5. So I'm going to group by ALK-Day5. And the summarize that I want to do is I want to count how many instances of that particular value show up. Okay. So I'll run this and then I'll talk about it a little bit more in case it's not clear. So when we run, okay, what we can see is the output in our console. We've basically looked at all the values, all the rows in our spreadsheet, in our data set, where ALK-Day5 is equal to 0. Okay. And what we can see with this N, this is counted how many rows have ALK-Day5 as 0. And it's 185,000. How many rows have ALK-Day5 as 1? 16,000. How many rows have ALK-Day5 equal to 2? 12,902, and so on. And what we can see down here is that this kind of looks like our culprit for what's messing up our data. We can see that ALK-Day5 is equal to 899 sometimes, okay? So why would it be equal to 899? That's clearly not allowed. This is often the case in a survey data set. You'll basically have numbers like this that indicate not missing data, but somehow this person refused to respond, or there's kind of some other weird thing, like there's some kind of flag that they want to attach. And you can look into the code book to see what 899 means. But for our purposes, what we want to do is we want to drop instances of BRFSS 2018, where kind of alk day 5 is equal to 899, okay? So we're going to use filter again. Okay, and what we want are only the observations in this data set where alk day 5 is a kind of a valid number, so less than or equal to 7, okay? So alk day 5 less than or equal to 7, this is now kind of the second element of this filter command. Before it was complete cases. Now it's less than or equal to 7, right? So kind of a different filter is being applied to the data. And when we run this, oh, sorry. What we should be working on is DAT, right? We want to be working on the data set that we've already dropped the NAs. So we're going to filter DAT, and we're going to drop any observation where alk day 5 is too big, okay? So we'll run this. Okay. You'll see that we kind of lost some more observations here. We should have lost about 1,330. And now finally, once again, we can try to find the mean of alk day 5. Okay, and we run this. Okay, and there that looks kind of more reasonable. We can see on average, people seem to be drinking less than 1 day a week. Okay. So, one good thing about kind of having written out our code in this script is, well, we can probably say that we want this to kind of occur right at the beginning. So what I'm going to do is I'm going to cut it with, Control X. I'm going to move it up here, right? We kind of want to do our data cleaning at the beginning, then start kind of examining the different elements of our data, okay? Now, when you move stuff like that, what you want to make sure always, like before you submit your homework, definitely is, you're going to want to save your script. So that's what I'm doing right now. I just clicked File, Save. Okay, we'll call this, our demo 1. And one thing that you're kind of always going to want to do is reload your kind of R script from scratch and kind of run it through line by line to make sure that kind of the final output that's being generated is what you expect, right? Because as we're kind of playing with, the data and like figuring out what works, we might be manipulating it in ways that lead it to look one way, but then we kind of run it through from the beginning. It actually doesn't look that way because we kind of took this weird path to get there. Right. So at the end, I'll make sure to kind of reload from the beginning and rerun our data to make sure that everything looks okay. Okay, so here we are. We figured out how to load in data, filter out observations that are kind of strange, that aren't informative, and to summarize the data in 2 different ways. One, by taking, just the mean of a particular variable, 2, by kind of doing the count of a particular variable. Right. And so we can also summarize multiple variables at once. So if we want to find, the mean of alk day 5 and the mean of something else, say nuvac 4, we run this, then we'll kind of be getting both at once. So here we can see on average in the data, alk day 5, people drink less than 1 day a week. And nuvac 4, 44.443. What does that mean? Well, recall nuvac 4 is a Bernoulli. It's between 0 and 1. So every time we have a 1, that's someone who got vaccinated, and every time it's a 0, someone didn't get vaccinated. 0.443, that's the average. That means that 44.3% of people got vaccinated, right? 0.443 is kind of the rate of vaccination in our data, right? If everyone was equal to 1, the average would be 1, the rate would be 100%. If everyone was 0, then that average would be 0. So the fact that some are 0 and some are 1 means that our average is going to be between 0 and 1, and it's going to give us that rate of vaccination. Okay. So good. So these are the summaries that we can do. We can also, take standard deviation using the command SD. And that has now appeared here. So this is the measure of the spread of each of these variables. Okay. All right, awesome. So we've cleaned the data. We've done some summarizing of the data. So now let's do some generating of new variables in the data. Okay. Actually, no, let's not do that yet. What we'll do is something to really help you kind of answer the questions that we care about, which are taking those conditional means that we talked about at the end of class on Monday, the 13th. Okay. So for conditional mean, we can just combine two things that we already have. So what we want to do is, let's say we want to find, the number of days someone is drinking in the past week by gender. Okay. So when we think, oh, I want to find, the average or the summary statistic of one variable, but only within a certain group, like group by group, and the groups are kind of indicated by a different variable, that's when we want to use group by. So we use group by, and our kind of gender variable is sex1. Okay, so we'll go group by sex1. And what we want to do now is, instead of summarizing and putting this n, if we put an n here, what will that do? So that will basically just count. Here's the number of instances in the data where sex1 equals 0. Here's the number of instances in the data where sex1 is equal to 1. Okay. But what we want to do is we want to know if there's a difference in drinking across the different genders. Okay. So here we are. We'll do summarize, and we'll take the mean of ALK day 5 by sex1. Okay. So select this, run it. And here's what we end up with. Here we have, for sex1 equals 0, the average number of days that people spend drinking is 0.932. For sex1 equals 1, the number of days that people spend drinking is 0.513. Okay. So for sex1 equals 1, people are drinking, half as much, half as many days per week, essentially, as sex1 equals 1. Okay. So like I said, sex1 is female, sex1 equals 0 is male. So, in words, we can say, okay, yeah, men are drinking a lot more days per week than women, in this sample, right? In this data set. Okay. Now, one thing that makes this, a bit challenging to interpret is, well, we have to think through, okay, what does sex1 equals 0 mean? Okay, that's male. Okay, so males are drinking more than females. Okay. We would like it to be more clear for any sort of person who's reading this output, right? And we're going to get ready to put it into a graph. So what we can do is we can create a new variable. So how do we create a new variable in R? So we need to use the mutate command. So the variable that we're going to want to create is a variable that is the name male if sex1 equals 0, and female if sex1 equals 1, okay? So the mutate command is what we need. And what we're going to do is we're going to basically mutate our current data set, DAT, and we're going to add in this new variable, which we'll call, now it's called gender, okay? And gender we'll see will be equal to, we want it to be equal to male if sex1 equals 0, and female if sex1 equals 1, okay? So we're going to use this command if else. If else is like a conditional statement. It's like, if this thing is true, then one thing will happen, but if not, then a different thing. Okay, and this is kind of similar to, again, like an Excel command where we're kind of conditioning on some kind of if statement, right? So in this case, the if statement is if sex1 is equal to 0, then we want this new variable to take the value of male. And if not, then we want to take the value of female, okay? Notice here that I use this double equal sign. So double equal sign is what we need to do for if we want to check whether something is equal to something else and to kind of return like, okay, is it true or is it not, right? So it's a logical operator, just like this one here is actually less than or equal to. So is AlkDay5 less than or equal to 7 or is it not, right? It'll tell us like, is that true or not, okay? Same thing here. So we run this. And what we can see is that in the top right here, it used to be 5 variables, now it's 6, okay? So if we inspect DAT, we'll see that this new column gender has been added here, right? So let's do dat group by gender, summarize mean AlkDay5. So same as the command on line 13, except now we're using this new variable gender. And this is more informative, right? We can see, how many days a week have like the males in this data set been drinking versus females in this data set. Okay, perfect. All right. This was a new variable that kind of, we used the if else statement and we kind of made part of our analysis more informative. There's other things, there's other ways that we might want to create a new variable. So for instance, let's say number of days per week spent drinking is not the outcome that you care about. What you care about is if someone is like a light drinker or not. And let's say a light drinker is someone who drinks 2 or fewer days per week, okay? So we can create a new variable, call it light drinker, and light drinker, we're going to say if AlkDay5 is less than or equal to 2, then yes, you're a light drinker, so this will take a value of 1. And if not, then you're a heavy drinker, and so light drinker will take a value of 0, okay? Now, why did I choose 2 days or fewer per week? It was arbitrary. You will be creating new data, new variables in your analysis, and you will basically have to make calls like that. Like if I'm coding something as a Bernoulli that used to have more values, a greater range of values, what should my cutoff be for the 1s versus the 0s? And we'll talk about that more kind of as we get into like the group project and thinking about like what it takes to sort of kind of do that convincingly. But for now, let's run this command. Now you can see we have 7 variables. We can look at DAT. We can see light drinker, okay, lots of 1s here. And that person who drank 7, yep, okay, here, they're not a light drinker. You can see that they're coded as 0, okay? So that's DAT. So we're interested in this different outcome variable, like are you a light drinker or not? We can, instead of summarizing ALK day 5, we can summarize light drinker. We run it, and we can see about 92% of women are light drinkers, as we defined it in our data set. 85.3% of men are light drinkers, okay? So that's kind of interesting. Like, this kind of tells a very different story, right? On the one hand, our previous analysis here says, well, females seem to be drinking kind of half as many days, just about, per week as men do, right? Women drink about 1 day every 2 weeks. Men kind of are drinking about 1 day every week. So you might think like, oh, interesting. Okay, so like men are just drinking, men are much like heavier drinkers. But when we kind of look at these numbers, it doesn't look like, men are that much heavier drinkers. Right, 85.3% are light drinkers, and 92% of women are light drinkers, right? Those seem fairly close together. So how do we kind of square that circle? How do we think like, okay, like what's going on here in the data? At this point, it would be good to have an intuition, right? So why would this number be so close to the female one, but this number be so far? Could be because, the heavy drinkers in the male population are very heavy, right? Maybe for them, it's like 7 days a week. Whereas for women, maybe the heavy drinkers are not super heavy. They're kind of 3 or 4 days per week. So that when you look at kind of the average consumption, those very heavy drinkers in the male population really skew things upwards. Whereas the very heavy drinkers in the female population, they're not that heavy, right? They're 3 or 4 days. And so they're actually not increasing the average by all that much compared to the 1 or 2 day per week drinkers, right? So that's one thing that you could choose to investigate. So I'll give you the tools on how to investigate that, kind of in the last bit here. But yeah, you can kind of do that, check that out on your own and see if you can find a reason or an explanation that satisfies you. Okay, perfect. So what have we done so far? Summarizing variables, creating new variables. Now we'll, in the last bit of this tutorial, we'll talk about plotting variables, okay? So what we'll start with is, in this tutorial, just histograms, okay? So we'll be plotting histograms. So there's basically 2 kinds of histogram that we can be thinking about here, okay? One is just looking at kind of a single variable and plotting kind of the frequency of the occurrences of the values of that variable in the data. Okay, so let's start with that. The beginning of every plot in R, as I'm teaching you, is going to be this command ggplot. ggplot stands for the grammar of graphics. Plots can get very complicated very quickly in terms of all the different elements on them. And because this isn't Excel and we're not kind of like manually editing each little bit here and there, we're generating it kind of directly from the data with something that can be reproduced by anyone. We need to kind of be very careful like about how we kind of enter in all of our plot specifications. ggplot helps us do that. So the beginning of ggplot is always, we need to tell which data are we using. And so we're using DAT, right? Our cleaned version of the data, all right? And then we do this plus sign, and this plus sign will basically be adding in kind of like the elements of the graph. So geom is typically the beginning of any graph. So when we enter in geom, we can see an enormous range of options here, okay? So there's a few that we're going to be using almost exclusively, but you can see there's a lot of stuff here, like geom map. So R is very powerful in plotting map and graph and geographic data very quickly. So geom line is kind of just like your standard line plot if you have kind of like an X and a Y. So we want to do G on bar. So G on bar is going to be our kind of histogram style plot. Okay, and now we can see there's a bunch of prompts in here: mapping, data, stat, et cetera, et cetera. So data we already have, so it's going to know that we want to use DAT. What about mapping? So mapping is going to be kind of our key. So we're going to use this command, mapping equals AES. AES is aesthetics. So aesthetics is kind of which variables do you want as kind of like your X variables, as your Y variables. For a histogram, right, for a bar plot, we know the only kind of variable we have is like, we have kind of frequencies of particular like values of the variable. Okay, so let me just type it in here. So for AlkDay 5, I've put in X equals AlkDay 5. So X is kind of like our X axis in the plot. So if we just kind of run this command, what's going to happen? So here's what happens. You'll notice the plot appears in the bottom right. It's switched us away from, packages to plots. It'll kind of keep track of all the plots you do. And what we can see is for each of the values of AlkDay 5, 0, 1 is missing, 2, 3, 4, 5, 6, 7. It gives us the count, how many times that observation appears in the data, right? That's what a kind of a bar plot does, what a histogram does. It gives us the frequency of each value in the data in the data set that we have, okay? What if we want not the raw count, but we want the frequency, right? We want to do something that kind of approximates the probability if this was kind of, approximating the true distribution of this random variable. So what we would do then is, instead of the default of just counting, we would do Y equals stat. And the stat that we want is prop, okay? Prop is proportion. Okay, so let's see if this works. Yes, okay. So stat prop, so now this is basically divided all of our kind of counts by the total number of rows in the data set, okay? And that will give us kind of the share of that particular value, that value's share of observations in the data set. So we can see, AlkDay 5 is 0. It's about 75% or so of observations. People are not having a drink in the past week. And then it's a huge drop, and then it kind of drops and drops and drops and drops. But then there's kind of like this big spike at 7, okay? So good. So that's our histogram. That's our plot. That's kind of like one variety that we can do. What else can we do? Well, one thing that we want to do is kind of compare our our means for men and women, for male and female, for AlkDay 5 in a graph, so that we can kind of like look at that and see it. Okay, so let's kind of look how we would do that. What we'll need to do is this output that we've generated. So we'll think about this AlkDay 5 one. Let's rerun it and see it. So what we want to do is kind of store this information in a new kind of little data set, which will then feed to the graphing to ggplot. Okay, so we'll create a data set that we'll call just, let's just say dat2, and we'll just run exactly this command. Not quite exactly this command, sorry. So one thing that we're going to want to do is notice that kind of this column name is kind of ugly. It's got these little quotes on it. So one change we're going to make to this bit of code is we're going to add in something before mean here, and we're going to say AlkDay 5. Okay, so we're gonna give it a name. so that when we run this, we see now we have gender and alk day 5 instead of this kind of ugly thing. And this is going to be more helpful because when we plot the data in this little tiny table, we'll be able to refer to alk day 5 instead of referring to this kind of ugly thing. Okay, so this is what we want. So we'll put this, I just cut and pasted it. And we'll store that little bit of that little 2x2 table into dat2. Okay, so now we can see dat2 has appeared. When we look at it, it's kind of exactly what we expect, right? Female, male, the averages, 0.51 versus 0.93. Okay, and when we plot this, we'll use ggplot again. Our data is now DAT2 that we want to be calling, and we'll use geonbar. And now our mapping, we want the aesthetic X to be gender, right? We want that to be along the X-axis, and we want Y to be alk day 5, right? This kind of mean value, right? And we need to include this little extra bit here, which I'll talk about in a sec. So now we have this. Let's run it. Okay. So here's what we have. We have our kind of graphical comparison. We have gender, male, female. On the x-axis, female's value is around 0.5. Male's value is around 0.9. Alk day 5, is the label on the y-axis. So we're kind of good to go. So we've kind of shown this relationship between gender and number of days in the past week spent drinking graphically, okay? So, one thing you may say is like, okay, this is fine, like this looks kind of ugly. Also, this y-axis is not very informative. If we want to modify the graph, all we need to do is start adding in more things. So if we want to change the X label, we can use this XLab. Just change it to capitalized gender. If we want to change the Y label, we use YLab. We've added that in there. And let's say that, days in the past. How many days? Did you consume alcohol in the past week? Okay. So if we run this whole thing, then we can see kind of our kind of more informative labels, right? You would also say, okay, that's good too. It looks kind of ugly with these big gray blocks. One thing that we can do to change that is we can add a fill, so a different color by gender, okay? So let's have that in there. Okay. And now we kind of have these two different colors. And this kind of little legend has appeared, which we don't really need in this case. It's a bit redundant. But yeah, so there's different colors. And the last thing you can do, just kind of like with any other plotting software, you can sort of change the aesthetic. So this is the standard theme. So we have other themes too. So if you enter theme underscore, black, white, classic, etc. So, if you're a classic person, and once we've added in that classic theme, that's starting to look a little nicer. That's starting to look like something that maybe, we could output as part of a report, or even on the homework, right? You don't need any of this stuff, right? All of this like labeling and kind of adding in the colors, but it does help the graph be a lot easier to kind of interpret, a lot kind of more visually exciting for your viewer or for your, whoever is kind of consuming this, this analysis output. Okay, cool. All right. So I think that should be enough for you guys to kind of do the homework. So I'll leave it there. If there's anything that I feel I missed, I may kind of add it in later onto the Quarkus, but this should be good for you guys. And yeah, of course, if you have questions, definitely reach out. When you're kind of going through this, maybe you've watched it through once at this point, you're probably going to be getting a lot of errors in your code, okay? R is very fiddly. Just like any kind of language, you need to obey its grammar rules. And here, the grammar rules you really need to be careful of are brackets, right? So brackets need to be matching up. So if we kind of go up to the top here, we can see this filter command. We have an open bracket, then we have another open bracket. You got to make sure you close every bracket by the end. When you click a bracket in RStudio, it'll try to find kind of the matching guy. If you don't have enough, if there's a mistake, it'll throw you a bit of an error. Typically, if you have errors on multiple lines, you kind of find the first occurrence. That'll be where kind of the real error is. So this is kind of like helping you diagnose these bugs in your program. Okay. So yeah, just be kind of very careful as you're doing the code. Follow what I'm doing exactly, in terms of number of equal signs, where the comma is appearing, stuff like that. And you should be okay. But yeah, of course, always reach out and come to office hours and come to the tutorial, and we'll get things straightened out. So yeah, very good. Good luck with your first homework. And I'll see you this coming week.